We're going to do a partial derivative example problem. So given the equation x equals e to the y times the natural log of z, we are asked to find the partial derivative of that function x with respect to y and with respect to z. So the first thing that we're going to need to know is that the derivative, write that here, the derivative with respect to x of e to the kx is going to be equal to k times e to the kx. So that is just saying that you take the derivative of this upper piece here and you move that to the front. We'll also need to know what the derivative of the natural log is, so that will just be the derivative with respect to x of the natural log of x, and that is just equal to 1 over x. So we'll move these over here for now, and we'll start it on this problem. So we are asked to find the partial derivative of that equation x with respect to y, and so we'll need to take the derivative with respect to y of this equation. So we'll write out e to the y, and then we're going to write out our constant in blue, so natural log of z. And you'll see that we can just move this to the outside of the derivative and just focus on that e to the y. And so that is just going to equal the natural log of z times the derivative of y is 1, so we'll write 1 here, e to the y. So writing this all out, we say that the partial derivative with respect to x, or the partial derivative of equation x with respect to y is just equal to e to the y natural log of z. This is just a long way of saying that the equation doesn't change when you take the partial derivative with respect to y. But it will change if we take the partial derivative of that equation with respect to z. So we're going to write out our constants in blue, so e to the y will act as a constant for this step, and we'll have the natural log of z. We're going to move this over, write out the derivative with respect to z. So we will move this e to the y to the outside and then just take the derivative of the natural log of z. So we'll get e to the y times 1 over z. What we're left with is the partial derivative of that function x with respect to z is equal to e to the y over z. Now for this next problem, we're given this equation u equals x to the fourth plus 2x squared y squared, and we're asked to find the partial derivative of u with respect to x and y. And so we'll write that out. We'll ask to find the partial derivative of u with respect to x. That's going to equal the derivative with respect to x times x to the fourth, and we're going to write out our constants in blue, so that will be 2x squared y squared. Now we can distribute this through and take out the constants, so that will leave us with the derivative with respect to x of x to the fourth plus, write those constants in blue, 2y squared times the derivative with respect to x of x squared. Now taking the derivative of these is pretty simple. Just move this term down and then subtract 1 from this term up here. So we can write all that out as the partial derivative of u with respect to x is equal to 4x to the third plus 2y squared times 2x, which can also be written as 4x to the third plus 4y squared x. Now for the second part of this problem, we're asked to find the partial derivative of u with respect to y. And you'll notice that not every term has a y in it, so you'll see what happens with that. We have the derivative with respect to y. We'll write our constants in blue again, of x to the fourth plus 2x squared y squared. So we can distribute this through, and we can take our constants out, and that will leave us with x, actually I'll write these in blue for now, x to the fourth times the derivative with respect to y of 0 plus 2x squared times the derivative with respect to y of y squared. So this term will go to 0, and 0 times x to the fourth is 0, so this whole term will disappear. And this term, it's fairly simple to take the derivative of y squared, so what we would be left with is the partial derivative of the equation u with respect to y is equal to 2x squared times 2y, which is equal to 4x squared y.